For the functions f of x equals x to the fourth plus 5x cubed minus 125x minus 625 and g of x equals x squared minus 25, determine a symbolic representation for the quotient h of x equals f of x divided by g of x using the table of values for each. Okay, so we want to find the symbolic representation for the quotient h of x, which we know is f of x divided by g of x. And notice here that they give us f of x values, g of x values, and h of x values. And since we're trying to find the representation of the quotient, which is h of x, then we can go ahead and find the finite differences here and find the function. And so let's first look at the x values and note the finite differences here. So 1 minus 0 is 1, 0 minus negative 1 is 1, and so on. We see that we do have a constant delta x of 1, and so we can go ahead and find our finite differences on the other side. So 31 minus 25 is 6, 25 minus 21 is 4, and so on. So notice here that we do have an error in our domain at -5, and we'll look at that a little bit later, but we'll just use our finite differences here for now. And then we'll keep going since we don't have a constant difference. So 6 minus 4 is 2, 4 minus 2 is 2, 2 minus 0 is 2, and 0 minus negative 2 is 2. And so we have a quadratic function, which makes sense because it's x to the fourth divided by an x squared equation. And so let's go ahead and use our rules to find the function. So first of all, using the rules, we know 2a is equal to the second difference, which in our case is 2. So dividing by 2 on each side to isolate a, we get a equals 2 divided by 2, or 1. To get b, we know a plus b equal the first difference between x equals 0 and x equals 1. So here that would be 6. And so then plugging in for a, we get 1 plus b equals 6. So subtracting 1 on each side, then we get b equals 5. And then c is our y-intercept. And so when x equals 0, then we see that h of x equals 25. And so we know c equals 25. So then substituting these into our function, then we get 1x squared, or just x squared, plus 5x plus 25 equals h of x. And then let's go ahead and address the domain issue we're going to have here. So with h of x equaling f of x divided by g of x, that means that we divided by x squared minus 25 on the bottom. And we just had our f of x equation on top. And the reason that this is important is that it cannot equal 0. And so when is x squared minus 25 equals 0? Well, factoring that, this is a difference of squares. And so factoring that, it would be x minus 5 times x plus 5. And so our zeros here would be when x is equal to positive 5 and negative 5. And so because of that, then we will have domain restrictions in that x cannot equal 5 or negative 5. And so we can write that as the set of x's such that x is in the real number set and x is not equal to 5 and negative 5. And that's because of having x squared minus 5 in the quotient in the denominator. So let's go ahead and summarize our answer. Since h of x is undefined at x equals negative 5 and x equals 5, there's a domain restriction for h of x so that the domain of h of x is the set of x's such that x is in the real number set and x is not equal to negative 5 and 5. The quadratic polynomial function is h of x equals x squared plus 5x plus 25 with a domain of the set of x's such that x is in the real number set and x is not equal to negative 5 and 5.